So we'll do some video notes for the first couple pages of Similarity. Most of this is review. Some of it's more complicated than other stuff, but it's all some material that you've learned probably at some point in 7th, 8th, or 9th grade, or a combination of them all. So what is a proportion? A proportion is basically two ratios which are equal. And ratio is the beginning of the word rational. So whenever you hear a rational number, it's got the word ratio in it. It means it can be written as a fraction. But it can be written two different ways. You can use a colon like this. You could say 2 to 3 equals 4 to 6. That's what the colon is. You say the word 2. So 2 to 3 equals 4 to 6. Or it can be written as a fraction. 2 to 3 equals 4 to 6. Either way. When we do the math, you'll probably find it easier to use the fractions, but it could be used either way. You can convert one to the other anytime you want. How do we determine if two ratios are equal? The old term is cross multiply. We'll use the term cross products, but when you have them written as fractions like we do here, you determine if they are equal. And notice I have a little question mark there because I want to know, is 2/3 equal to 4/6? Well, we find both cross products to see if they are equal. So a cross product going this way, 6 times 2 is 12. Cross product going that way, 4 times 3 is 12. So because 12 equals 12, those were in fact equal ratios. If you didn't get the same number both times, then they were not proportional. They were not equal ratios. Now sometimes you're going to have a variable. So now we're down here. How do we solve a proportion? Well, if you have a variable involved, like here we didn't. Up there, we just had numbers. We were checking to see if they were equal. But if you do have a variable, then you are being asked to solve. Okay? So in this case, 6 over 5 equals what over 15? So we set up the cross product the same way. We just write a cross product equation, 5 times x and 15 times 6. And 5 times 5x equals 90. 15 times 6 is 90. Don't get hung up on these calculations. Have a calculator next to you ready to go. Divide both sides by 5. And again with the calculator, 90 over 5 is 18. Here's the same idea, except we're going to have a binomial. So anytime you have anything that isn't just a monomial, put it in parentheses. And we'll set up the cross product going this way, 3 times x, and the cross product going the other way of 6 times x minus 6. Now you might notice right away that you have to distribute that 6 to get rid of those parentheses. So 6 times x is 6x. 6 times negative 6 is negative 36. So we distributed to get rid of the parentheses, and now I'm going to take away 6x from both sides. 3x minus 6x is negative 3x. And divide both sides by negative 3, and x is going to equal 12. Similar on the last one. 2 times x equals 1 times 21 minus x. Well, when you distribute a 1, nothing really happens. 1 times 21, 1 times negative x. And in this particular case, I'm going to add x back to both sides. And I'll get 3x equals 21. So x is going to be 7. Okay, here's where it gets a little bit interesting, because now we have, I guess you'd call them word problems, right? So the ratio of boys to girls in the class is 4 to 3. And every time I had something to do with boys, I put it in reddish, and every time I was talking about girls, I put it in greens, and I organized it that way the whole time. So boys to girls is 4 to 3. So you can see how I set that up right here. Boys to girls is 4 to 3. And said if there are 20 boys in the class, how many girls are there? Well, if 20 has to do with boys, then it has to go on top where the boys were, where the 4 was, and now where the 20 is. And It wants to know how many girls there are. Well, how many? We don't know that. So that's where the variable x comes in. Now we have a problem just like we had up here when we practiced. 4 times x equals 60. Divide both sides by 4, and there will be 15 girls. However, the next one is a little bit different. Notice I introduced a different color here. Boys to girls is now 1 to 3. So I set it up the same way over here. But then it says if there are 28 students, so that's like total humans, not boys or girls, but people collectively together. So if there are 28 total students, how many girls are there? Well, I'm going to put 28 students. I don't know how many girls there are. That's what I'm looking for. How many? And girls was 3. So girls was green, 3. But what's total people? Boys and girls together. 1 and 3 together is 4. So sometimes you might have to add things together if you're talking about a total situation. A little bit tricky. So 4 times x is 4x. 28 times 3 is 84. Divide both sides by 4, and x equals 21. There are 21 girls. So in that case, we had to total the boys and girls together because we were talking about total students. Number 3, we are talking about angles in a triangle. Well, first of all, let's look over here. All angles in a triangle, we know that that adds up to 180. So if we're talking about angles, we know we have 180 that we're trying to equal. So whenever you have a ratio like this, 1:2:3, meaning 1 to 2 to 3, that really means 1x, 2x, 3x. So I'm going to call that angle 1x. The next one's a little bit bigger, so twice that, 2x. And the purple one is 3 times bigger than the green one, 3x. I don't know what they are, I just know that this one has another one that's twice as big as it and another one that's 3 times as big as it. So x plus 2x plus 3x equals 180. Combine those like terms, that's a total of 6 x's, now equals 180. So x is 30. Now I wanted to know the size of each angle. Now that I know that x is 30, well then this one's 30, twice that is 60, and 3 times that is 90. The next page is similar, kind of like a model of each one all over again, after number 4 anyway. Number 4, what are the possible names for the quadrilateral with sides 3 to 1 to 3 to 1? And I drew 3 possibilities here because I want to teach you rather than quiz you on it. First one looks like a rectangle, right? Well, what this means here is that we have 4 sides, and it looks like we have 2 that are identical and another 2 that are identical. But the 2 sets of identicals are different than each other. So the 3s are the same but bigger than the pinks, which are the same but smaller. So we have 2 sides that are triple the other 2 sides. That's why it can be a rectangle, because if this was 1 and this was 1, they would have to be the same on a rectangle. These are different, but they're the same as each other. So those could both be 3. So one possible name for this could be a rectangle. But that's not all. It could also be this. That could be 1, that could be 1, and these could be the same as each other but bigger. So it could also be a parallelogram. What about a square? Because this is the same as this, and this is the same as this, but the difference there is we need a pair that's bigger than the other pair, and a square does not have that. A square has all 4 the same, so it would not be a square. This one doesn't work. It also wouldn't be a rhombus. So it could be a rectangle or a parallelogram. Number 5 is similar to one on the other side. I did everything in water in reddish and everything in powder in green. So water to powder is 4 to 3. So if you use 10 cups of water, and water goes on top because it's been on top the entire equation, how much powder? How much? I don't know. X. So we cross multiply. 4x equals 30. Divide both sides by 4. Now it looks like I'm going to get a decimal there. 7.5 cups. Number 6 is that total thing again. Just like this one on the first page, we have a soccer club with a ratio of 3 to 2 juniors to freshmen. So I set that up right away, juniors to freshmen, 3 to 2. But if a club has 45 total juniors and freshmen, they're saying that that's a group, juniors and freshmen total, how many juniors are there? Meaning, we're looking for the pink, the juniors. Well, there were 3 parts juniors, but what's the total parts? Because it has to be juniors to total equals juniors to total. The total there isn't 2, it's 5. It's 3 and 2 together. So whenever you have that total situation, you add them together to make 5. So 5x equals 45 times 3, which is 135. We're going to solve for x by dividing by 5. And x is going to be 27 juniors. So 27 juniors out of a total of 45 students. And the last one, the sides of a triangle are in a ratio of 3 to 8 to 7. So just like before, except this time it's not talking angles. So actually I'm going to move these. I copied this from before. We're talking about sides of a triangle, not angles. So sides. See how this one's different? It's not going to be the 180 because we're talking about sides. So we can't use 180. They have to tell us the perimeter if they're going to go with sides. They don't have to tell us the total if it's angles because we know that's 180. But every triangle is a different size, so we don't know how big that is. So the 63 has to be given to us if we're talking about distance and sides. So we have, and it doesn't necessarily matter what order you put it in, 3x, 8x, 7x. So 3x and 8x and 7x add up to the 63. So that's a total of 18 x's equals the 63. Divide by 18. Again, this is where you can't get bogged down with a calculation like this or give up because you don't know what it is. Use your calculator. 63 divided by 18 is 3.5. But it didn't just ask us for x. It asked us how long is the shortest side. Which one's the shortest side? Forget about what the picture looks like. The shortest side has to be the 3x, because 3 parts is smaller than 7 parts and 8 parts. So this is where in geometry you never trust a picture, you trust the numbers. So 3x has to be the smallest side. So 3 times x, or 3 times 3.5, is 10.5 centimeters is the length of the smallest side. I should probably do that in green so it matches. So you're going to try assignment number 40, which is all of page 3.